Okay, so hi everyone. Today we're going to be talking about momentum. Okay, and I want to inform you that this subtopic, I'm going to divide it into two parts. Okay, the first part is today. We're going to do the fundamentals of momentum. Okay, and very basic basic calculation. And then the second part, which will be next Tuesday. Okay, I will announce this again later. Next Tuesday, I will do part 2 at 10 a.m. Okay, so for those of you who are from SC and also ST, you're definitely more than welcome to join us. I want to inform you it's Tuesday at 10 a.m. Okay, the part 2 session for this. Okay, but for the most part, on part 1, there's not going to be that much demonstration today. But it was most likely more of it is going to be on the PowerPoint now. Okay, so another thing that I want to remind all of you also is especially if you have homework, please ask your respective teachers if you have homework that you need to complete. Okay, because I'm responsible to teach. Okay, but I'm not responsible to give you the homework lah. Okay, so for people under Cikgu He and Cikgu Fiona, Cikgu Farhana, you should ask them if they have homework for you, and if you have homework with them, please make sure you complete their homework. Okay, but if you want me to answer anything, if you want to ask me any questions, feel free. Okay, feel free to ask me. You can get my number or my Telegram contact from anyone in 4SA. All right, so let's start our study in momentum. Momentum actually has a lot of things that are closely related to inertia. Okay, so these are very various examples of momentum. I hope you all have watched the video that I passed to you so that all this will make sense when we talk about it. Okay, we find that any object that moves, okay, whether you're catching a ball or whether the ball is flying, whether this, how many of you know what this is called? Okay, if you don't know what this is called, this is a good time to find out. Go and Google. Okay, find out what this is called. Okay, or if somebody is, shooting this is not a rifle, it's probably a water pistol. Okay, but if somebody is shooting something, there is momentum involved here. Okay, when a plane is flying through the air, momentum. When a rocket is flying upwards, all this has to do with momentum. Okay, momentum and the thing that we're going to learn in a while. Okay, so question, softball player, okay, must wear a glove to catch a hard and fast moving ball. Okay, a slow moving softball is much easier to catch. Okay, the question is why? Okay, so, oh, sorry. Okay, oh no. Okay, oh, sorry. Oh, okay. So, we'll answer in a while. So, for example, this now, okay, you're given these two situations over here. One is a car that is moving at 30 meters per second at first, and the other one is a lorry, okay, a much bigger and heavier lorry, and it's also moving at the same velocity. So the question is, compare the velocity and the time it takes for the lorry and the car to stop. Okay, and we learned this in the last lesson. Which one is harder to stop? The answer is obviously the lorry lah. Why is it harder to stop? And this is where all the explanation that we talked about earlier comes in. Okay, because number one, the lorry has a bigger mass. Therefore, it has a bigger inertia. Okay, that's why it's harder to stop. Okay, so we find that it takes a longer time, okay, for the lorry to stop. This is an example lah. So, for example, the car stops after 60 seconds. Okay, and then the lorry takes a longer time to stop, although they were starting at the same velocity. Okay, so just like this, a big cargo tanker is difficult to stop than a car moving with the same speed. Same speed, sama-sama laju. Tapi why is it that the car is easier to stop? The cargo tanker, okay, is more difficult to stop. Okay, so another example that I want to draw is if I'm using the same lorry now. Okay, if I'm using the same lorry, and let's say this lorry is moving at 5 meters per second at first, and 30 seconds later, it stops. Okay, it is much easier to stop the same lorry if it is moving with a low velocity. Okay, so just now, if you remember previously, previously it took me 180 seconds to stop the lorry because the lorry was originally moving with 30 meters per second. Okay, but now kalau asalnya lorry itu bergerak dengan 5 saja, it takes a shorter time for it to stop. So we find that it is not just mass that plays a role, okay, in the stopping of the lorry. Okay, it is also the velocity. Sebelum ini, when we were talking about inertia, we only related it to mass. Now we're going to relate it to velocity. Okay, not inertia, but actually we're going to relate to momentum. So let's take a look at this situation. Okay, so this situation is to study how the mass and the velocity of an object influences the effect of stopping the object. Okay, so we have these two objects. This object, which is a golf ball, and then there's a plasticine over here. Okay, if this was a normal class, I would have done it in the lab, but well, MCO is MCO. And this is a golf ball, same golf ball, but we drop it at a higher this one. Okay, I'm going to give you 10 seconds just to look at these questions and try to answer it for yourself before we discuss this. Okay, so the first question is, which golf ball hit the plasticine at a higher speed? Okay, the answer would be the ball B lah. Okay, because we already learned this. It has more space to cover, therefore, although the acceleration is the same, the velocity will increase even more. Okay, then second question is, compare the depth of the cavities made on the surface of the plasticine by the falling golf ball. Cavity means, let's say ini golf ball jatuh bahkan, cuba kamu bandingkan dia punya kedalaman lubang itu. If I take away the golf ball, okay, we are going to be left with a lubang lah. Okay, and obviously we find that ball B, dia punya, this plasticine over here will have a deeper cavity. The hole will be bigger. Okay, so which golf ball has a bigger effect of stopping? The answer will be ball B. Then the effect is bigger because dia punya speed adalah higher. Okay, we're going to come to this. We're going to continue. Okay, so now let's compare another thing. So we're comparing the effect of, sorry, I can't see this. We are going to compare the effect of stopping something lah. Okay, with a golf ball. Okay, with different masses moving at the same speed. So now, different balls. So this is a golf ball. This is a ping pong ball. But look, they are both at the same height. Okay, as opposed to the situation before this, same ball but different height. Now is same height but different ball. Okay, so golf ball, ping pong ball. Which ball has a greater mass? Okay, the answer will be the golf ball, obviously. Okay, unless a golf ball is a trick ball, or your ping pong ball is a trick ball. Okay, but generally the golf ball will be heavier than the ping pong ball. So think, which ball will fall and make a deeper cavity on the surface of the plasticine? Okay, dia punya lubang lebih besar. Kalau dia terjatuh di plasticine kan, mana yang akan membuat lekuk, okay, or hole lah, okay, that will be bigger. The answer will obviously be golf ball. Okay, so C question, which golf ball has a bigger effect of stopping? Okay, sorry, I don't think this is, actually it's which ball has a bigger effect of stopping, not golf ball, not which golf ball. Okay, antara golf ball and ping pong ball, which has a bigger effect? We find that it is the golf ball. Okay, so before I continue, and I know that we've learned this, but I want to establish this fact. The first question is asking situations of different velocity. We find that the one with a bigger velocity has a bigger effect of stopping. Okay, point number one. Bigger velocity means bigger effect of stopping. Second point is, we find that the golf ball, which is the one with the greater mass, okay, has the bigger effect of stopping. So this bigger effect of stopping, actually dia dipengaruhi oleh dua perkara. One is velocity and one is the mass. Okay, so let's state how the effect of stopping objects in motion depends on the mass and the velocity of the object. Okay, so we find that the effect of stopping object is bigger, okay, if the mass and velocity is higher. Just like that day when we were talking about inertia, remember there were two people running, okay, and then I don't remember who's stopping us. I think it was Melanie. Okay, me and Valerisa, we were both running, okay, but Melanie was stopping us. So whose effect is going to be bigger, the stopping effect is going to be bigger, is obviously me, okay, because my mass is higher. But we find that now that we are studying one level up, okay, since you are going into momentum, we also have to talk about the velocity. Something that is running faster, okay, has a bigger stopping effect. Okay, So let's say Valerisa has a twin, or I have a twin, okay, and both of us are running, but although both of us are the same, let's say Marcus A, Marcus A is running faster than Marcus B. Okay, so Marcus A is going to be harder to stop, okay, because his effect of stopping is going to be bigger. Therefore, okay, this is the relation we need to talk about. The greater the momentum, the greater the effect of stopping object. Okay, something that has a bigger momentum is going to be harder to stop. But there are two factors that affect the momentum, which is number one, the mass, and number two, the velocity. Okay, and this brings us to this one. Every moving object has momentum. Okay, momentum can be thought of as a tendency of an object to keep on moving with the same speed in the same direction. Okay, the word momentum itself, actually, kalau kamu Google dalam kamus, the word momentum itself is, the desire to keep on going. Okay, in the same speed, it's a tendency to keep on moving. So actually, there are some people that say that, if inertia is part one and then momentum is part two, because they are talking about almost the same thing. They are actually connected. Okay. So momentum often indicates, menunjukkan the difficulty a moving object has in stopping. Okay, so momentum is the measure of how hard it is to stop an object. A fast-moving car has more momentum than a slower one of the same mass. Somebody asked me in the previous class, can inertia be measured? Okay, which my answer is cannot. Okay, which is probably why the scientists came up with a way to describe the difficulty of stopping a moving object, the stopping effect. Okay, and that's how they come up with momentum. Because inertia, as I said, is a concept. Momentum is a physical quantity that we can measure, we can calculate, and we can have a value. So that value will tell us, the bigger the momentum, the bigger the stopping effect. Okay, it's harder to stop something with a bigger momentum than it is to stop something with a smaller momentum. Okay, so according to Newton, the object with less momentum is easier to stop and gives less impact in a collision. Okay, for example, if you're riding a bicycle very slowly and you crash into a tree, okay, you won't get so injured lah. Okay, as opposed to if you are riding a bicycle very fast and then you suddenly crash into a tree. I don't know why I'm saying crash into a tree, but fine. You crash into a tree, obviously you will have there's more impact on you because you're going faster. Okay, although your weight is the same. Okay, so that's why a baseball player must wear a glove to catch a hard and fast-moving baseball because the ball has a very big momentum. Tengok walaupun dia begini kecil kan, but because it's moving very fast, okay, the momentum is still very big. Okay, I mean ini baru baseball lah. Can you imagine if somebody throws a bowling ball very fast? Okay, lagi lah besar momentum. I don't think the glove will be enough. You need like something else lah. Okay, so it is difficult to stop the ball and will give larger painful impact when it hits the player's hand. Okay, so all this has to do with momentum. So now we come to the formula that you are supposed to already know if you have watched the video, which is the definition of momentum. Momentum is the product of mass and velocity. Hasil darab jisim dan halaju, okay, is momentum. Okay, so it's given by this symbol. P, actually this P is a small p, it shouldn't be a big P, okay, but small p equals to small m times small v. Okay, so momentum equals the mass multiplied by the velocity of the object, okay, or basically just this mass times velocity. The good news about momentum is that it is one of the formulas, it is one of the definition yang sama dengan formula. Usually, like acceleration, rate of change of velocity, okay, it's not final velocity minus, you don't define it that way. But momentum, you can define it by using the formula itself. Okay, so momentum equals to mass times velocity, the product of mass and velocity. Okay, so the vector quantity, okay, the unit for momentum, mass is kilogram. Okay, I'm going to highlight this. Mass is kilogram. Okay, oh, yellow color highlight. Oh dear, so ugly. Okay, and I wonder if I can change the color. Oh, I can. Okay, and velocity, meters per second is V. Okay, so it's a very easy unit to remember. Dengan syarat yang kamu ingat the unit for mass and velocity separately lah. You just combine it together. Kilogram times mass per second. Okay, so I'm going to give you some time. Take a look at these two questions. Okay, and I want you to calculate the momentum of both players separately. Okay, not together. And then in this situation, calculate the momentum of Granny and Boy. Okay, I'm going to pause the video for a while to give you some time to calculate. Okay, so we find that in the first example, you have a football game and this 70 kilogram mass is moving with 4 meters per second, and the other player with a mass of 75 kilogram, which is heavier, but he's moving with a smaller velocity. Okay, so we calculate the momentum of both the players separately and we will get this lah. So the 70 kilogram one will have is just momentum times his velocity, which is 280 kilogram meters per second. 75 one with 75 times -3. Okay, so we are again still have to take into account, okay, the direction of the velocity. Okay, because remember, velocity is a vector quantity, it's not a scalar quantity. How many of you did 75 times 3? Begitu saja. Okay, it's negative because this guy is moving to the left. Okay, one football player, this guy, okay, the 70 kilogram is moving this way, whereas this 75 kilogram is moving this way. Notice that the velocity, the direction of the velocities are different. Okay, that's why this number has to be negative. Okay, so we find that even momentum, okay, we need to take into account the velocity's direction. Okay, don't just take the number only. Okay, so I know it looks like a very simple calculation question, but the point of this example is to remind you that velocity kita masih kena ambil kira the direction. Kalau ke kiri is negative, kalau ke kanan is positive. Okay, and likewise with example 2, iaitu Granny with 80 kilograms whizzes around the ring with a velocity of 6 meters per second. So kita anggap dia pergi ke sebelah kanan. She suddenly collides with her grandson, who is at rest. At rest means, correct, Umar. Okay, so at rest means the velocity is, oh dear, look at me, I'm trying to write with my mouse. Okay, the velocity is 0. So since this guy is not moving, obviously his momentum is going to be 0 lah. Okay, manakala the granny who is moving to the right, okay, is going to have a momentum of 480 kilogram meters per second. Okay, so the point of these two examples is just to show you how to calculate momentum correctly. Okay, all right. Now this brings me to the principle of conservation of momentum. Okay, and the principle of conservation of momentum is quite simple. It states that, okay, the total momentum, okay, in a system, okay, the total momentum in a system will remain constant if there is no external force acting on the system. Okay, that means, for example, in the case of both the football player and the granny, misalkan, dia punya jumlah momentum, okay, before and after colliding with one another must be the same. Okay, in the same way like the granny and this grandson, their total momentum before the granny bangs into the grandson must be the same as the total momentum after the granny already banged. Think about it, if the granny banged the grandson, right, where are they going to go? Are they most likely they're going to be traveling together? Okay, let's say this is the grandson and this is the granny. Okay, this is the grandson, this is granny. So granny is coming. Wow. Okay, most likely they're going to go together. So before they crash into each other, okay, the momentum here, the total momentum, okay, is the same as after they crash into one another, they're going to move. Okay, this principle of conservation of momentum needs to be understood this way. Before they collide, okay, before mereka berlanggar, their total momentum separately must be the same as after they collide, okay, their total momentum separately also. Okay, you count one by one, their total momentum is the same. Okay, because after you collide kan, sure mesti salah satu daripada ini akan berubah. The boy will suddenly have velocity, the granny will probably reduce the velocity. Obviously the weight doesn't change, the mass doesn't change lah. Okay, kalau selepas kita berlanggar kan, terus kita punya jisim badan berkurang kan, saya mau sentiasa berlanggar dengan orang. Okay, but in reality, it doesn't work that way lah. After you crash into somebody, your mass still remains the same. The only thing that changes is your velocity, which is why the total momentum will always remain the same before and after you collide with one another. Okay, so this one. In short, in short, total momentum before collision, okay, equals to the total momentum after collision. And these two examples are actually given in your textbook. Okay, for example, you have these two bombas. Okay, they are, at first there's nothing. Okay, they're just holding the pipe there and they're not doing anything. But suddenly, the water inside the pipe, they shoot out keluar. Okay, with a certain velocity lah. Okay, therefore, these two what will happen to them? Think about it. If you have a very high speed water coming out of the pipe, right, what's going to happen to you? You can't be just staying there, but okay, and law physics tells us that ini dua orang ni mereka akan tersentak ke belakang. Okay, and we find that here the total momentum is zero, okay, because dua-dua pun tidak bergerak. Air tidak bergerak, bomba tidak bergerak. So both velocity is zero. So the total momentum before is zero. But because there is this velocity moving forward, okay, the two of them, okay, their velocity is going to be backward and is going to be negative. Okay, so because of that, okay, these two, the total momentum is also going to be zero, which we will calculate in the next class. I just want you to understand this principle first. This principle takes a bit of time for it to sink in, okay, which is why I purposely set this class as two different parts. Because on a Friday afternoon, kalau saya mau terus mengajar calculation even I will fall asleep. Okay, so I just want you to understand the principle first. Okay, same thing like the rocket. Okay, when the rocket is not moving, okay, sebelum dia kena launching, okay, the total momentum is zero. But the moment it starts to go up, there is a velocity upwards. Okay, for the rocket which must be balanced, okay, by the momentum upwards, okay, the momentum m times v, the mass of the rocket times the velocity, must be balanced by the velocity that is downwards. And what do you think is the mass that is involved here? Okay, it's obviously the mass of this one, this thing over here. Okay, the smoke, the fire, the explosion okay, the mass of the gases bila dia ter-explode ke bawah, okay, it will explode with a certain velocity. So these two are balanced. Okay, this one, and remember, positive is velocity upwards is positive and velocity downwards is negative. Okay, so we find that the total momentum is also zero, equal. Before zero, after zero. Okay, but it's not always zero, guys. Ini contoh sahaja. Okay, if let's say, okay, for example, okay, let's go back to this one. What is the total momentum here? 280 plus, oh dear, look at my horrible mouse, minus 225. Okay, so what is the total momentum here? It's my calculator. 280 plus negative 225. Okay, you will rightly get, and okay, Dina, I said 55. So you get 55. Okay, so the total momentum of these two is 55 kilograms meter per second. Okay, wow, guys, have you ever tried writing using your mouse? It's such a torture. Okay, so we find that, okay, then we think, what happens to these two players after they crash into one another? Okay, after they crash into one another, they probably will, they will probably move together. So after they crash into one another, their total momentum is still going to be 55 kilograms meter per second. Tapi, adakah diorang punya momentum individually still remains at 280 and negative 225? The answer is no. Okay, after they crash into one another, after they collide, only the total momentum is the same. The individual momentum will be different. Okay, but you will still have to follow this principle. The total momentum is the same. Individual momentum is different. Okay, which we will calculate in the next part. Okay, I just want you to make sure that you understand this one. Okay, just like this, Granny and Boy. What is the total momentum before? Total momentum before is 480. Okay, but What if they already crash into one another and then they continue to move? Okay, Granny's momentum won't be 480. And the boy's momentum definitely won't be 0 because he's no longer resting. Okay, he's already going to move together with Granny. So the momentum will change, but the total momentum will still be 480. That's the important thing about the principle of conservation of momentum. Total momentum before collision is equal to the total momentum after collision. Individual momentum akan berubah. Okay, for example, the momentum of the rocket and the momentum of the gas will be different. Okay, before and after collision. But diorang punya jumlah must always remain the same. Okay, Umar, what do you not understand? Sorry, can you, if you have a question, yeah, try to ask that publicly. Which one do you not understand? It takes a while. Okay, it takes a while to the granny one. Okay, let's logically think this through. Okay, forget the maths for a while. Okay, we talk about the granny one first. So, I hope you understand this part. Ini sebelum mereka berlanggar. Okay, sebelum mereka berlanggar. So we find that since the boy is not moving, he has a momentum of 0. So they're at rest. But the granny is moving with 6 meters per second. So she has a momentum of 480. Okay. Now, think about it in terms of after the collision, after they have already crashed into one another. Okay. Imagine this is you and this is me and this is you. Okay, if I crash into you, you are going to move already. You can't be staying still over there. You're like, oh, okay, saya tidak terpengaruh pun oleh orang yang berlanggar dengan saya. It doesn't work that way. You have to move, okay, because I crashed into you. So if I'm already moving, means my velocity won't be 0 already kan? I will have a velocity. If I have a velocity, means saya punya momentum akan berubah sudah. Dari kosong pergi, contohnya dari kosong pergi 120. Let's say my momentum after you crash into me is 120. So what happens to Granny's momentum? Granny's momentum will berkurang because principle of conservation of momentum say before collision must be the same as after collision. So if after collision the boy is 120, the Granny dia punya this one will probably be 360 because 360 plus 120 is equal to 480. Okay, ini adalah okay, I'm going to use a different color now. Okay, this one is before. Okay, before they collide, the total momentum is 480. But after they collide, lepas diorang berlanggar makan, then we are talking differently. Granny's momentum becomes 360 and boy's momentum akan jadi 120. Tapi jumlahnya tetap sama. Okay, the total is still the same. But the individual yang, Granny punya akan berubah, boy punya akan berubah. Tapi jumlah mereka bersama-sama tidak akan berubah. That's the principle of conservation of momentum. Okay, I hope that answers your question. I hope so. Okay, all right. Thank you very much. If you don't understand, it's okay. You can keep asking again. All right. Okay, so I'm going to show you this situation over here. Okay, so this diagram shows two brothers are skating. Okay, the elder brother moves and collides with his younger brother who is at rest. This guy is not moving. This guy is moving. Okay, what is the movement after the collision? What do you think will happen? The speed of the elder brother will probably what? Okay, so let's take a look. The speed of the elder brother will decrease. Okay, because the speed of the younger brother will increase. Okay, the balance is always there because the total momentum is always the same. Momentum of the elder brother will decrease. Dia mesti sekali dengan the speed. Manakala the momentum of the younger brother, because his speed is increasing, therefore the momentum of the younger brother will increase as well. Okay, and that's how the principle of conservation of momentum works. Total momentum sahaja yang sama. Okay, but the momentum before and after will change. Okay, let's take a look at this. Flick a 20-cent coin A directly to another one. Okay, this one, kalau kau selalu main masa sekolah rendah kan, this is what, dulu kami main dengan menggunakan penutup botol cap. Okay, so what happens to the motion of both coins after the collision? Okay, there could be one of two, but this answer says coin A will stop and usually coin B will move forward. Okay, usually lah. Okay, sometimes you get coin A and coin B moved together, but usually, you know, when you flick, okay, when you flick this one over, then you know we find that coin B moves forward. Okay, what happens to the momentum of coin A after collision? Since coin A is stopping, after the collision, lepas mereka berlanggar, lepas mereka berlanggar, the momentum of coin A decreases. Okay, of course, because the momentum is transferred. Okay, the momentum is transferred over to coin B. Okay, but the total momentum, again, I'm saying this many times until dia termasuk di kepala sudah. The total momentum of both before berlanggar, after berlanggar is the same. Okay, cuma ada sedikit yang terpindah pergi ke B. Okay, but the balance is still there. Okay, another situation. This one also, I think, you know, a lot of kids in primary school will always do this one. Okay, so let's describe the motion of all the coins after collision. You know, you have A and then you flick it over, B and C are joined together and they're not moving. Okay, so let's talk about coin A. Coin A, it will stop. Okay, coin B also stop. And coin C, it will move forward. If you don't believe this, you go and try. Seriously, you take a few 50 cent or 20 cent coin, kasi 50 cent is a bit difficult because now our 50 cent kan dia tidak bulat sudah, but I think it can still work. Okay, you try to do it with a, you know, a round coin lah. Okay, you find out that actually B will stay still. Okay, and only C akan disang. Okay, so what happens to the momentum of coin A after collision? It transfers over to coin B and to coin C. Okay, and this is how this thing works. Okay, as I said just now, if you don't know what this is, go and find out. Okay, ini sebenarnya dipanggil apa? Okay, this one they just say steel ball, but there is a word for this whole thing altogether. So there are 5 balls over here. Okay, if you've ever seen this video before, you know what's going to happen. When A hits B, and then E naik, and then turun, and then A naik. And then B, C, D is just sitting down there doing nothing. Okay, because what happens to after the steel ball A hits the steel ball B, okay, ball A will stop, ball B, C, D will also be stopping, only ball E will move upward, okay, and will be about the same height as ball A, okay, which is about here lah. Okay, the question is the momentum conserved? Okay, is all the momentum in A all transferred over to E? Okay, the answer is yes, because it reaches the same height. Kalau let's say, okay, let's say this is the ball A starts from this height. Okay, it hits, and then tapi ball E tidak sampai setinggi, it doesn't reach the same height as ball A originally, means momentum is not conserved. Something has gone wrong there lah. Okay, bukan rosak, okay, but it's just the momentum is not conserved. Means there's some momentum yang lost. Okay, we need to ask why the momentum is lost lah. So predict what will happen if 2 balls, A and B, are pulled then released. Okay, if you have this thing, you can actually try it out for yourself. If I pull A and B, both the balls together up, and then I let it go, okay, what will happen is, ball A and B will stop, C will also stop, and then D and E will move upward to be at the same height as A and B. Okay, there are many videos that you can view on this. If you have this thing, okay, which I'm not going to tell you what is this thing, you should find out for yourself. If you have this thing at home, it's a good time to play with this. Oh, okay. Very good, Newton's cradle. It's called as Newton's cradle. All right, good job. Okay, so actually, that's all I want to do today. Okay, that's all I want to do today with regards to this, this slide. I only want you to understand 3 very important things. Okay, 3 very important things. The first one is what affects momentum. Okay, there are 2 factors that affects momentum, which is mass and velocity. Secondly, I want you to know what is the definition of momentum, how to count momentum, which is mass multiplied by velocity. And the third thing I want you to understand first, before we go into the second part, is the principle of conservation of momentum. Okay, remember that the total momentum before berlanggar must be the same as after dia berlanggar. Okay, this is difficult. This is a difficult subtopic for some people because of the calculations that come after this. Okay, but I think that if you take it slow, okay, and since we are MCO anyway, we're not really rushing to do anything. So take it slow, try to understand the principle of conservation of momentum as it is. before the collision, total is the same as after the collision. But individually, they will be different. Okay? Because the next class, next Tuesday, when we do the next class, okay, kita akan membuat pengiraan. And the pengiraan is a little bit complicated in that sense. Somebody is asking me to repeat, but repeat bahagian mana? Sorry, I don't know who this starry eye is. So you got to identify yourself and you have to tell me which part you want me to repeat. There's a lot of parts to repeat. Which part are you asking me to repeat? The things you have to remember. Okay. So first thing you have to remember is that momentum is affected by two things. Okay, momentum is affected by the mass and the velocity. Okay, bigger mass, bigger momentum. Like me and Valerisa, kalau kami dua lari-lari, I'm going to have the bigger momentum because I'm bigger mass. Okay, not body shaming, but I'm just admitting my mass as it is. Okay, secondly, it is also affected by velocity. The faster somebody runs, the bigger his momentum is going to be. Okay, which is why after you run 100 meters, right, the moment you cross the finish line, you don't just stop there, okay, you find that a lot of athletes, lepas habis 100 meter kan, they will run a bit more and then they will slow down there. Nobody immediately stop begitu. The moment you finish the 100 meters, okay, it's suicide. Not suicide lah. You menyusahkan diri sendiri. It gives you a lot of injury. Okay, so the two factors that affect momentum is the first thing. Second thing that I want you to remember is the definition and formula for momentum, which is momentum is mass times velocity. Is there a situation where both objects' momentum will suddenly stop? Yes, there is a situation which we will talk about on Tuesday. Okay? The third thing that I want you to remember is the principle of conservation of momentum. Principle of conservation of momentum says that total momentum before equals to total momentum after. Okay, although actually individually the momentums will change, but the total will remain the same. I'm actually very intrigued with this question. Somebody asked me, is there a situation where both objects' momentum will suddenly stop? I think there is. Okay, okay, the easiest example I can give is the one that I gave just now. For example, if I'm cycling, okay, and then I run into a tree, then my momentum will suddenly stop. But both objects, okay, fine. If you have two people running into each other and both suddenly stop, then both the momentum will be stopped. But because one is positive direction, one is negative direction, so their total momentum, okay, will be zero. Then after they crash into each other, the total momentum will still be zero. Okay, there are actually many situations where the object's momentum will suddenly stop. Okay, it all depends on the situation and also the calculation. Okay, but today I don't really want to go into complicated calculations because number one, it's a Friday. Number two, it's a Friday afternoon. Okay, so I'm going to keep things simple. Tuesday morning, okay, when you wake up fresh, hopefully you wake up fresh on Tuesday morning. Okay, then we will do more complicated stuff. So how is it possible to conserve momentum when there's so much external force around us? Okay, that's a very good question. Okay, so the principle of conservation of momentum, okay, works in a very ideal situation. Okay, right now at the Form 4 level, kita selalu membincangkan case ideal. Okay, just like when we were doing free fall, okay, this is the reality. Okay, whenever we do calculation, this is the reality. The reality is the feather will fall slower than the ball bearing. Okay, but whenever we calculate something, okay, for example, I gave this as your assignment. Whenever you calculate this, for example, tennis ball is released, falls vertically from a building of height 15 meters. Okay, and then all of you immediately say, okay, the G equals to 9.81. Because the thing that we are doing is that we are ignoring the air resistance. Okay, because at Form 4 level, we assume everything is perfect. Okay, there is no air resistance, and the object is only falling at gravity 9.81 meters per second. If you go into higher level physics, then you have to consider this air resistance part already. Okay, but for now we're introductory level, so we are only assuming that there's no air resistance. So in the same way, just like this person asked me, how is it possible to conserve momentum? It's possible in a very ideal situation, which is what we're talking about now. Okay, maybe if you're interested, you go to higher level physics, then yes, correct. There's going to be a slight problem. You have to, you have to make adjustments to the calculation. You have to factor in other forces such as, resistance, friction, personal things. Okay, all those things, yes, definitely will contribute to the not so conserved momentum. It's a very good question. Okay, it is a very good question. Thank you for asking that. Okay, any more questions? Because actually we're not done. Sorry, I'm done with the lecture part lah. Okay, yeah, Tuesday next week. When Tuesday apa lagi? Before. All right. So let's do a couple of exercise questions. Okay. So for example, this a 1,200 kilogram car travels at 20 meters per second. Okay. What is its momentum? Is the question. Sorry. Okay. All right. So this is very simple. The mass is given here, and the velocity is given here. So the momentum. Oh, sorry. Did you see what I'm writing? Hold on. Oh, this is harder to annotate. Okay, when am I? Oh dear. Sorry, I'm going to stop sharing this first. Next technology is not very helpful. Okay, so we have P, okay, equals to, oh dear. Okay, jangan kecam, saya punya tulisan yang sangat buruk ini. Okay, so this will be 1,200 times 20. Okay, so you get 1,200 times 20, you get 24,000 lah. Okay, you get 24,000. And then don't forget the unit for momentum. Okay, the unit for momentum is kilogram meters per second. Okay, yeah, this is torture actually, doing this. Okay, then the next thing is, okay, if the, oh no, even this I cannot padam. Yeah. Okay, the question is, if the car in the previous question slows down to a stop, okay, what is its final momentum? Okay, so the important thing to note over here is this one, the word stop. Oh no! Sorry. What is the color that I want to use? I'm going to use blue color. Okay, stop. Oh no, it still doesn't work that way. Okay, never mind. Obviously, I'm not very good at doing this annotation thing. So anyway, the word is stop now. Okay, if the word is stop, then if the car has come to a stop, the final momentum will be 0. Okay, and then for those of you who watch the video, okay, the question is, what is the change in momentum? The change in momentum will be 2,400 minus 0. And if you watch the video, you will know that this change of momentum, the name is called impulse. Okay, but we're going to talk about impulse in another subtopic. It's actually 2.7. But I thought since we're talking about momentum, you might as well watch the video to understand that change of momentum. Okay, the word change of momentum actually means impulse. Okay, which we will talk about in 2.7. Okay, so hold on for a while. Okay. Oh, this is more difficult than I thought. Okay, then next, if the car slows down in 5 seconds, what force does the car experience in braking? Okay, I'm going to stop this question first because this is not the question that we want to answer today. Okay, I just want you to make sure that you know how to use the momentum formula. Okay, and then to understand that if something is stopping, the momentum is 0. Okay, and for those of you who watch the video, the change in momentum is just, the final momentum minus the initial momentum. So actually, yeah, it should be negative now, negative 1,200. Okay, second question, or fifth question, sorry. So while catching an egg, the receiver gives, okay, with her hands and arms. Yeah, I'm not sure whether you played this game. Last time kalau di kampung kan kami panggil semakin jauh semakin sayang. Have you ever played this game before? Semakin jauh semakin sayang. You have 2 people, you stand in front of each other, and then you throw egg to one another. Then if you catch the egg successfully, everyone takes one step back, begitu. So while catching an egg, the receiver gives with her arms and with her hands and her arms, okay, making the stopping time of the egg about 7 times longer than if it were caught stiff arm. Okay, if let's say the egg is coming to you from very far, Okay, you're not going to put your hand there and be very keras, kan? You're going to catch the egg and you're going to, go behind the bin. Okay, so this one, by what factor does the force encountered? Okay, by what factor does the force encountered by the egg change? So actually, what changes? What are you actually doing? Okay, when you're putting the hand, further and further behind, you're actually decreasing the velocity slowly. Okay, you are decreasing the velocity slowly so that the change in momentum is not so drastic. Okay, everybody knows this. If you put your hand very keras and the egg just drops on you, the egg is going to break. Okay, you will lose the game. Okay, but if you bring your hands behind after you catch the egg, you're actually letting inertia work, but at the same time you're helping to make it stop gently. Okay, because inertia will make the egg break. Okay, they suddenly stop like that, no choice. But momentum will definitely make the egg break. Okay, but if you can help by reducing the velocity slowly, then you will reduce the chances of the egg breaking. Okay. Question: what is the momentum in kilograms meter per second of a 62-gram golf ball traveling at 73 meters per second? The answer is not 62 times 73. Okay, why? The reason is because this 62 is in gram. Look at the unit that we want for momentum. Okay, it's in kilogram. So how do we change gram to kilogram? We divide by 1000. Okay, so 62 divide by 1000 dahulu, baru kamu darab dengan 73. Okay, sorry, I'm not going to annotate this because it's this one. All right, the rest of the two questions I won't answer for today. Okay, we will answer it when we come to that subtopic. Okay, but the thing about this exercise, the reason why I want to show you this exercise is this one. First of all, to use the momentum, this one. And secondly, to remind you that the mass must be in kilogram, okay, which is the SI unit for mass. Okay, so, and because the unit for momentum is also kilogram meters per second. Okay, so please, whenever you see a number, make sure the unit is corresponding with the formula that you want. Okay, don't just, automatically 62 times 73. Okay, must think a little bit when we talk about units and numbers. Okay, so for today, actually that's all our class. I want to remind all of you once again, especially for those of you who are 1 minute. I want to remind all of you who are joining the class for part 2. Part 2 will be next Tuesday. Okay, next Tuesday at 10 a.m. Okay, be ready to do a lot of calculations because the part 2 part is the calculation part. Okay, the calculation part can be a little bit confusing, so try to sleep early. Okay, on Monday night. Okay, and then I will see you on Tuesday.